Hi there. I'm Jordan Dukes from Megaport. I'm the Director of Strategic Solutions. I cover a whole bunch of our alliance partners, but spent a lot of time as of late trying to develop and kind of evangelize some new solutions around AI, obviously being top of mind for so many. So I wanted to talk a little bit about our AI exchange and actually hopefully provide a demo to you and show you how in about 5 minutes we can connect a private cloud compute environment in AWS over a private connection to one of our NeoCloud partners like DigitalOcean and leveraging their AI GPU droplets product. We have all that automation built in our platform along with DigitalOcean. So before I do that, I'll give you a little primer on what Megaport is for those who don't know. Megaport is a global SDN network as a service platform. And one thing that's really important to highlight is that we have real kit, real routers, switches, optical equipment sitting in racks at 1,000 data centers around the globe. We just recently crossed the 1,000 data center mark. And we announced it at the NASDAQ in New York about 2 months ago. But as I said, we've got a huge amount of kit and compute and networking capacity out there deployed around the globe. And what this allows us to do is be proximate to all of the most important cloud on-ramps, build adjacencies and connectivity to all these NeoClouds, CoreWeave, Latitude, if you're leveraging Google Vertex or SageMaker and AWS, we have all that connectivity already locked in and connected to our platform. So we're able to go out and orchestrate services across all this equipment across the globe and do it in 30 to 60 seconds. We've built our orchestration platform from the ground up. It's been in place for, I'd say, about 13 years now. As you can see here, we're across 26 countries, 2,800 customers, 280 cloud on-ramps, so lots and lots of capacity and reach. Most recently, we've upgraded most of our core backbone to 400 gig. It's native 400 gig, real ZR plugs. It's not 4x100, so we have the ability to launch 100 to 400 gigs of capacity literally instantly. And there's different ways to get to our platform. And a few of the partners we have out there as well. I was going to highlight some of the edge providers that we have for one of the ways that you can access web through one of these devices, whether it's Fortinet, Palo, Cisco, an encryption device like Aviatrix. These are ways that you can come in potentially publicly, but most of the time we're connecting customers in with cross connects and data centers to give them that private, secure, high capacity access that they need. So this allows us to deploy a plethora of services, but primarily we're doing site to cloud, cloud to cloud, DC to cloud. The virtual edge product I mentioned, that would be like an SD-WAN access method. That's one way to come in as well. We have IX capacity as well that you can reach through our platform. But what I'm focused on today is how we're going to build connectivity from some of these cloud environments to what everyone's interested now around NeoClouds, as I mentioned, like Latitude or Vultr or CoreWeave, who already have capacity built with us across the globe. So a little bit about how the ecosystem works and how we're going to plug things together. We're the middle mile provider here. And you can see you've got a customer coming in, whether it's SD-WAN or coming in across the internet, or most likely coming in across a dedicated 100 or 400 gig cross connect in a data center across about 130 different data center operators. That's, again, one of the big differentiators for us is our fabric is agnostic. It allows you to go across that boundary, that DCO boundary, which can be so important when you're bringing together different organizations. And again, in reaching back out to our partner ecosystem on the right and being able to plug all these pieces together using these different connectivity methods. So what I want to really focus on today, our AI exchange. Naturally, we ended up getting a lot of partners and these new cloud providers wanting to join our ecosystem, right? It's that whole network effect. Moore's law. We're building this ecosystem that allows you to connect to more and more things. We have customers that connect to other customers with private connectivity. And again, leveraging all of those traditional clouds, AWS, GCP, Azure. But now with all these new emerging NeoClouds, we're able to bring all that private connectivity into and out of these different AI providers or GPUs as service providers. What this does is provides you a platform for arbitrage, because you can go out and then find the right compute in the right location for the right price, and not necessarily be so locked into leveraging AWS or Inferentia or NVIDIA GPUs. You're paying top dollar pricing on one of the big public clouds. This allows you to go out and kind of look at the market and then be able to move that workload from place to place. So if you want to train up a model or move the data to a location where you would train a model, you can do that now privately, securely, on demand, leveraging our platform, as opposed to exposing that all to the internet. One of the things we've been spending a lot of time looking at is as enterprises train up models, all the data, it could be decades of data, they're going to use to train that model. They need to get that to a location to start that training process. Potentially, it's a massive security risk because you're putting in, HR, sales, ops, finance, all this data to help train up a model that potentially they'll end up inferencing against in the future. So it's kind of like the crown jewels of an organization. So our philosophy is it makes sense to keep that as absolutely secure as possible, and our backbone is completely secure and private. So I mentioned a few of these, like Grok, Vulture, DigitalOcean, who's what we'll have demo today for you. We've got Akamai on there as well. CoreWeave, of course, is emerging to be a real player in the space. They've got multiple 100 gig links onto our platform. So if you're a customer of Equinix, you can come across our platform, hit a number of other DCOs, but also now reach out to all these different emerging cloud providers that aren't available on other fabrics. So now kind of getting to the technical piece, and I'll try not to do death by demo here, but what we were going to build and show you here is leveraging a cloud router. So Megaport has this virtual device called a cloud router, which is portal based and allows you to deploy essentially up to 100 gigs of packet forwarding power, all on demand within a couple of minutes, and then cross-connect that between multiple clouds. In this case, we're going to cross-connect between DigitalOcean and AWS. So I might have a workload sitting in AWS today, but I want to go over and leverage these AI GPU droplet functions that I have capacity for over in DigitalOcean. I can move that workload over with a private connection. So if the video is going to play well for me, we'll see if it works here. But I'm going to kind of walk you through what this looks like and how we build that connectivity. Let's see if this will play. There it goes. So what I wanted to show you here, this is what our AI exchange looks like, all the providers that are in there. Here I want to go to DigitalOcean and see what kind of capacity I have. And what I'm going to do is end up leveraging a 100 gig link that we've got over there in JFK, and I'm going to cross-connect that back through to AWS. So this is our portal. So I'm going to go in and I'm going to look at data centers in Ashburn. Double click in. I'm going to find the data center that I want to deploy my cloud router, again, which is going to connect. It's the construct that will connect those two workloads. So I've built out the cloud router here. Click through the portal. I'll pick the speed, anything from 1 gig up to 100 gig of forwarding capacity. Build this out. And then you'll see as we click through, it'll give me the pricing, what I need. Once I have this MCR built, we have the ability then to go add those connections. And I'll show you, most importantly, the automation that we've built in with DigitalOcean. So it's going to ask me to put in ASN numbers for the MCR that I'm going to be leveraging. Click through here. I'll have a couple more prompts. Now I'm going to actually go out and deploy that MCR. See it over here. The services are starting to build out. And now I'm going to add my connection. And here's the automation that we have with DigitalOcean. Go over to my DigitalOcean portal, and the ability to go in here now, look at my VPC private compute. I want to build a partner attachment. I'm going to go through here. It's going to provide me with all the details, the routing elements that I need, ASN number, local IP, peer IP address. I'm going to take all this information, and then it will populate that back in my cloud router on the Megaport side. You'll see here. Finalize that, and what this is going to do is going to build create a service key for us. That service key is what allows us to go over to our portal and then connect those two workloads together. So here you go. You see it. I'll build this out. There's my service key. Going back over to Megaport, put that in. I've now built that connectivity between that cloud router sitting in Ashburn, Virginia, across that link in JFK to DigitalOcean, and I've now built kind of one leg of that stool that you saw in the drawing previously. So the next step for us is we want to go out and build the connectivity over to AWS as well. So I'm taking all those BGP elements, the IP address, the ASN number, local IP, pure IP, populating that in, everything that they provided me on this side. So I can then establish BGP peering between DigitalOcean and us. And then what's left is just to go over to the AWS side. There you go. So you can see that connection is now built. We have one more to go. So I'm going to look for AWS. I'm going to build out a hosted connection. Find the most proximate. That's literally an on-ramp in the data center where that cloud router is established. Build out the connection name. Make that a gig. And with our API with AWS, we don't even have to populate the IP addresses in this phase of the connection. AWS will provide that for us. And once I finish this up, add the connection. That connection is instantly received on the AWS side. You go to your AWS dashboard. I'll see that connection waiting for me to accept and then tie into my private compute over on the AWS side. You see these connections that connection is now waiting. Now we're going to go over and accept it. DigitalOcean just came up and BGP is established there. You can see it's established on the DigitalOcean side. I should be exchanging BGP routes. Now I go over to AWS. There's the connection that we just sent over to AWS. I'm going to accept it. It's down, waiting to come up. We'll associate with a direct connect gateway. Now you can see both sides, both connections into that cloud router are now established. I have BGP connectivity on both sides. I'm going to go over here and look at our looking glass to confirm that routes are being exchanged bidirectionally. Connected. I want to see that I'm receiving routes from AWS on the DigitalOcean side. You can see those. And continue to confirm, and that's basically it. We now have connectivity between those two workloads. And again, we did it with 1 gig here, but that could be a 400 gig connection. Again, all private, on demand. You finish moving that workload over, you can take it back down. You can build it at any granularity you want, but it's really about being flexible and agile as we figure out how much capacity you need, how much latency is important for some of these workloads. Inferencing is certainly different than training an LLM. So if you need to have that high performance, really close to the edge user type inferencing, latency value, we can get that as close to the customer as you need because we can move it to any data center on the globe essentially. So that's really it. And if anybody has any questions about it, I'd be happy to field them. Go ahead.
So for DC to DC connections, we'll have to pay a price for the port upfront, right?
For the port, you pay a monthly price for the port, and you establish your cross connect with your data center provider, and then that gives you connectivity to our platform to do anything you'd like to do at that point.
And then we pay for the traffic that
Yeah, and with us, it's not metered, so it's a flat rate. So you establish a 1 gig connection, it's unlimited for that point A to point B. So there's no metering at that point. And of course, with the cloud providers, typically on egress, you're going to have an egress cost per gig. One of the benefits here, like we established this direct connect, that's about 70% less per gig to egress out on a direct connect, a private connection versus over the internet. So there's a big benefit to the cloud costs that you'll be incurring as well.
And it's fully diverse.
Fully diverse. Our entire backbone's diverse.
No fiber cut, undersea cable cut will impact.
We have 2 to 3 routes into and out of every one of our data centers. For transatlantic, I can think of 3 routes on the map right now. So we lose one, you may have a slight latency hit, but you'll have another path. And then of course we always have redundant kit, red and blue side. So if you want to be completely diverse in terms of the way you're connecting that last mile into DC, that cross connect, we'll bring you one cross connect into one side of the network and the other into the other. And if we ever do network, maintenance or something like that, we never take down both sides at the same time. So you're always protected. Question though. Well, thanks everybody. I appreciate your time.